is Mr. Logan and I are doing everything together. We're our little team. So he has 3 sections of geometry honors. So do I. He has, I think, 2 on an odd day and 1 on an even day. So do I. So the problem is when we have days like this, cell day we're having tomorrow, that's on the cultural and religious observance day, because that affects our 6th and 8th period classes, in order to keep you all together, it affects you. Now, if it had fallen on a red day, then we would do what we did before and just put black in the lead. And we would teach the black, the new class, and you guys. Remember for a while, the black day was in the lead. So if, snow days happen or something like that, and it happens to a red day, we'll just put you guys following the black day. But having you guys be 1 or 2 lessons ahead of the black is just difficult for everybody to keep track of. Can you please? So there really shouldn't be anybody walking in and saying, wait, what, we have a quiz, because here's today, and then here's when your quiz is. Got it? So you might want to make sure that you check out that schedule. So we are going to do an activity today, and we'll talk about that in just a minute, but I want to make sure that you are all caught up on what it is that we need. So for example, your favorite question, what's on the quiz, is answered by looking back at what have we done. So we talked about coordinate geometry, distance, midpoint, and slope. That's fair game, because that's what we did before the quiz. Ratio and proportion, understanding geometric mean and scale factors. That's all stuff that we're going to talk about today with our activity. Similar polygons, defining what it means to be similar, and then how we go about proving similar figures. That 2-page homework, if any of you have any questions on it, I'll be glad to answer it today. We'll quickly go over it when I see you on Wednesday, and then that's when you'll have your quiz. At the meantime, I want to make sure that you are aware of your midterm approaching. So your midterm is on February 16th and 17th, depending on whether I have you even or odd. That's up here. So we're here where the lizard is. So that's in about 2.5 weeks. And what we've done is we've designed eCart reviews for each unit, where we're asking you to page 3 your notebook and go ahead, log on to eCart and take the quiz. You have an infinite number of attempts to try to get as high of a score as you can. At the end, we add up all of your scores and count it as one quiz grade. So there's a huge opportunity for you to have a very strong 3rd quarter grade. And I can't tell you, every year it shocks me how many kids do nothing and end up with a 50% quiz grade. And then their moms are emailing me and the kids are crying and I didn't know. And I have so little patience for that, because if you're busy doing something else while I'm talking and you miss what it is I'm talking about, then that's your consequence. So that's what's on the quiz for next class. Everybody okay with the schedule? Cole, put your head up. Take a look at what I'm talking about. So let's talk real quickly about the eCarts, because I will go in and grade the eCarts once. So and this is what happens with this infinite number of tries. If you take it again and again and again, then your new score is just what's then reflected. So when I go in and I grade them, if you go in afterwards and retake it and get a different score, I won't know, because it is what it is when I go in. Does that make sense to you? So I'm not going in until the day of the midterm. And on the day of the midterm, I'm going in and I'm grading them. And any work you do after that won't count. Go ahead.
So let's say you take the quiz and you get like a perfect score, but you decide to take it again for some reason and you get one wrong. Does it show the most recent one or the best score?
It shows the most recent.
Okay.
So if you don't want that 9 out of 10, go in and take it again and get a 10 out of 10.
Yeah.
Are you with me?
Yeah.
Okay. Yeah, it shows whatever you score most recently. That's what I see when I go in. Okay? Any other questions about the e-cards? Would you please do me a favor and turn to your partners and talk about the midterm e-cards so I make sure that you understand what it is that I'm talking about with deadlines and such. Talk it out. Go. So next I want to talk about homework 6-2. Mason and I were just talking. He's like, this was a pretty big homework. Was this all due today? No. Because, again, of our even class period friends, they don't have their class regular tomorrow. So that then you are responsible for having this homework done on Wednesday. Does that make sense to you? So if you want to take it out right now, and please ask a question about anything that maybe gave you trouble, take some time to scoot through. We kind of rushed through class last time, and I want to make sure that you have the time to ask your questions. And what's interesting is because we did similar triangles before, or congruent triangles before, you should feel fairly confident that you understand the process that we're going through. We can define similarity, we can prove similarity, and then we can use similarity. So it's that whole idea of what is it, how do I prove it, and then how do I use it. So if we're given here that this pentagon is similar to this pentagon, if we're given similarity, what does that mean? What that means is that every single angle, corresponding angle, is congruent. And if the polygons are similar, then all the corresponding sides are in proportion. And you absolutely have to take a look at the way that the letters are listed to know how the shapes are oriented. So these two shapes, my smaller and larger one, are a flip or a reflection of the other one. So if I'm given that they're similar, then I can use the fact that all the sides are in proportions, and I can set up a proportion where I compare x to 2, CD to JK, and DF to KL. So once I set up my proportion, I use my cross products to solve. Not a problem. What's interesting about this second proportion here is that I take the time to make a second comparison. So here I'm going from corresponding side to corresponding side. This second proportion, I'm sticking within the figure, CD to 9. This to this is going to have the same relationship as that to that. And if you look at these two proportions, that's one of these properties that's going to be on the quiz. Sumner, are you with me? So what I'm looking at here is I just switched my means. So each of these proportions have to be justified. If I say to you, why is this okay? Your answer is you switched your means, which you're allowed to do, because at the end of the day, you get the same cross products. You're multiplying 6 times x still, and you're multiplying 9 times 2 in both. That's what justifies our being able to write different proportions to represent the same problem. Lots of kids asking me questions about what is the ratio of their perimeters. Because these two have a relationship between each other, 9 to 6 or 3 to 2, I know that this figure is 1.5 times bigger than this. I know that this figure is 2/3 the size of this one. So the way that we mess around with those scale factors ends up being dependent on which figure I'm talking about and in which term. Am I talking about a scalar? What do I multiply one by to get the other? Or what is their story if I set up a proportion between the two figures? That ratio of their perimeters is going to be the same. This is just a linear length and a measure around. So if this figure is 1.5 times this one, the perimeter is going to be 1.5 times. If this figure is 2/3 of this one, the perimeter is going to be 2/3. So that scale factor needs to be written either as a ratio of big to little or represented as a scalar. Questions on that? Okay. The next thing I want to talk to you about is if you look over here on the back of the first page at a problem like this, if it helps you to redraw these triangles so that you're looking at your big and your little triangle. If you have a hard time seeing the two triangles here that are similar, then go ahead and draw them each separately. Because if you look at these two triangles, these lines are parallel, and that's what gives us our corresponding congruent angles. This angle is congruent to itself by the reflexive property, so I know I have angle-angle similarity. Right away, I know that angle-angle similarity because all of the angles are congruent. So when I go to set up my proportion, I can compare, and here I compared the length of my big side to the length of its corresponding part, 5 plus x to x. Here I compared my longer side, 19, to the shorter side, 12. Kids were having a hard time seeing that with this figure. My number one hint when solving this is make sure you bubble wrap this algebraic expression and use the distributive property when you're solving. Any questions on any of these that you encountered while you're doing your homework that you need me to talk about? Go ahead.
The last one.
Yeah?
Like, how do I set up the equation for that one?
So again, we can, if you want me to, we can draw the two triangles. I have my smaller triangle here, and I have my bigger triangle here, right? Sully, because these are parallel, I know that these two angles are congruent because they're corresponding. These two angles are congruent because of reflexive property, so I've got angle-angle similarity, right? This is an 8 and 10 measurement in these two sides. This measurement here is going to be 8 plus 3, so that's going to be 11. And then this side length here is going to be x. So when I set up my proportions, my corresponding sides, I can set up 8 is to 11 as 10 is to x.
Oh, I got it.
Okay. So what we ended up talking about with this one in 5th period is the numbers are not all pretty. We're super used to the numbers being pretty. So if it doesn't work out evenly, you're like, oh snap, maybe I messed up, and you go back and you check it one more time. But you think about it, what are the chances of things working out evenly in real life? Not that great, right? Like you go to a 7-Eleven and you buy a snack, if the cashier says that'll be $8, you're like, even? Like seriously, $8 even? Like you're surprised that it came out even. And think about it, you had a 1 in 100 chance of it coming out even. That's not so bad, right? But if you're talking about what are the chances of these measurements coming out even, like you're talking about all the possible numbers in the whole wide world, that's pretty impressive, right? So we need to get used to our numbers not always being so pretty. Sound okay? Okay. Anything else that you want to talk about in doing these problems? Any questions that you had when you were doing your homework that were hard that you want me to go ahead?
That one right there.
Which one?
The 11. Yeah.
Okay. So this one's a great question. So you should think about this every time that you encounter a ramp that is handicap accessible. To comply with the American Disabilities Act, wheelchair ramps made for new constructions have to have a height to length ratio, not ratio of 1 to 12. So that means for every 1 foot of vertical height the ramp goes up, that height has to be spread out over 12 feet. So we're talking about a 1 to 12 in order to not have too steep of a ramp, right? And that takes up an awful lot of space. Any of you think back to your time at Herna Middle School? If you go up the steps by the auditorium, that's the only place where when they did the renovations there, they didn't have enough linear length to fit a ramp in. That's the only steps that are not also accommodated with a corresponding ramp. Think about the ramps going down to the cafeteria and everything else. You know which steps I'm talking about above the auditorium? Used to be where the Spanish rooms are. I don't know if they were still there. All right, so on a new construction, the height to the bottom of a door is 2.5 feet. And we want to use a proportion to estimate the length that the ramp should be in order to have the correct slope ratio. And then in the proportion use A is 1 foot and B is 12 feet. Okay. So if I know I need a 1 to 12 story, let's go and identify what we have. The height to the bottom of a door is 2.5 feet. So this height is 2.5 feet. And this A value, see this arrow here? This is 1. So if B is 12 feet, I need to set up a story where I know that 2.5 is to 1. Here's this height is to this height, as my new R is to my B. So that would be the ratio that I would set up. Does that make sense? Anything else I can answer from your working on it? Okay. So this homework is going to be due next class. We'll talk about the answers and then you'll have a quiz. Go ahead.
Can you show the proof?
The proof, sure. So if I'm looking at proof number 1, I'm being asked to prove that the triangles are similar. And when I'm proving similarity, these are my options. So congruence, I have 5 options because I have angle, side angle, and I have hypotenuse leg. For similarity, if I have 2 angles, I'm already set, so I don't, angle, side angle is not a part of it because I need at least 2 sides to show a proportional relationship. And if I have 2 angles, I'm already there. Why was I able to cross off side, angle, side, inside, side, side for this one?
The side's not congruent.
Yeah, I don't even know what the sides are. Anybody see any numbers there? Like, there's not even a single proportion for me to check. So someone's like, hey, are they proportional? I'm like, hey, I don't know. Nobody gave me a single number. So for me to check for corresponding sides being in proportion to other corresponding sides, I'm going to need some more information that they haven't given me, so I'm moving on to something else. Which means I have to rely on angle-angle similarity. These 2 lines are parallel, and I'm telling you right now, take the time to go ahead and extend those lines, because once you extend those lines, I can see this is my transversal. Once I know that this is my transversal, no part of the picture is on the opposite side of the transversal, so there's no alternating interior or exterior angles involved. So I can start ruling out things that I'm not going to use because of what I'm given, information-wise. So I know then that these 2 angles are congruent because they're corresponding angles for parallel lines. given a transversal. This information here is where I find out that M and N are right angles. So I have enough information to prove angle-angle similarity. Now what I need to do is be sure to put it in a way that I didn't miss anything and that it makes sense. So first of all, I'm going to need to say that this is what's given. And then I'm going to need to say that angle MRS and angle NST are congruent because they're corresponding angles. Then I'm going to need to state that these are perpendicular because that's what I was given. By the definition of perpendicular, M and N are right angles. And since all right angles are congruent, angle M is congruent to angle N. So then I've got my two triangles congruent by angle-angle similarity. Question for you, am I allowed to call this angle M and this angle N?
No.
Yes. Am I allowed to call this angle S?
No.
No. Do you see the difference? We can have a discussion about angle R and angle T. Because angle T, I know that there's another angle pictured here, but this is the only one that is in reference to a triangle. The better answer is no for that one and for R. But S is definitely confusing because since there's two angles for the two triangles there. So we don't want to say angle S. That's not going to be enough information for us. Sound okay? Any other questions? All right, so here's what we're going to do next to see how it works out. So what period 5 did was I had this cartoon, and I love this cartoon, like man plus the spear plus, I think it's a bear or a buffalo.
Buffalo.
Yeah, okay, a barrelo is a fat man. Get it? A man minus the spear plus the barrelo is a fat barrelo. Get it? I find that funny. So what we did was we took this comic, and I have this lovely grid that it's a transparency that I can put over top of the comics, and I can do a photocopy, and then I can cut it all up into little pieces, little square pieces. And then each of you gets a square, and your job is to recreate your drawing on, so you go from a 1 by 1 inch square to an 8.5 by 8.5 square. Now Nora's already commented, mine's a rectangle, not quite. You're welcome to measure and fold to be more precise. We did the best we could cutting. So if you choose to be a little bit more meticulous, then obviously you're welcome to.
Hey, this was supposed to be finished an hour ago, and I thought you were painting both of us. Well, if your head's that big, where am I supposed to fit in? Dear Tim and Moby, how do I scale something I want to draw? From Lucky One. Well, you start with the thing you want to scale. Moby's supposedly making a mural of this picture, but I think he needs to put down the paintbrush and do a little math first. Our picture measures 10 centimeters by 15 centimeters. Now, we measure the surface we're transferring the image to, in this case, the wall. It's 3 meters by 4.5 meters. To find the scale of Moby's painting, we need to make a ratio, the actual height of the picture over the scaled height. That's 10 centimeters over 3 meters. Sure, we convert the meters to centimeters to make it simpler. 3 meters times 100 centimeters per meter is 300 centimeters. simplify this ratio to 1 to 30. So our height scale in centimeters is 1 to 30. 1 centimeter on the picture is 30 centimeters on the wall. Let's do the same for the width. The picture is 15 centimeters wide, and the wall is 4.5 meters wide. 4.5 meters is 450 centimeters. Our ratio simplifies to 1 centimeter over 30 centimeters. Great, our width scale is also 1 to 30. That's good, because when your height and width scales are different, you end up with a stretched picture. Now we know that 1 square centimeter on the picture equals a square 30 centimeters by 30 centimeters on the wall. And here's the trick that makes scale drawing easy. We make a grid on the picture, dividing it up into 1 centimeter boxes. Then we do the same on the wall using the scale of our ratio. Since our scale is 1 centimeter to 30 centimeters, our grid on the wall divides the wall up into 30 centimeter squares. That way, 1 block on the picture will be scaled to 1 block on the wall. Now all Moby has to do is paint what's in the picture on the wall square by square, and his mural will be to scale. Well, sure, I'll start you off. See, it's just a matter of copying the information in this 1 by 1 centimeter square to the 30 by 30 centimeter square on the wall. There. That looks pretty good. Now we just pencil in the rest of the squares in the grid, paint it, and we're done. Moby?
Okay. So that's kind of cool. So what we're looking at, this is going to be our comic that you're going to do for your class. Plain geometry is hard enough. What will fancy geometry be like? The 2 kids leaving school. So what I have is the grid marks over it, and each of you are going to get a square. Now your squares are in black and white, so I'll leave this comic up while you're working. But I want to go through so you understand what it is I'm expecting you to do and what I'm grading you on. Okay. So you're going to take a square from the baggie and a pre-cut piece of white paper. You're going to write the letter and the number on your square here, and I'll come around with tape so you can tape it down so it doesn't get lost or fly away. Draw what you see on your little square onto the big square and think of a plan first. So sometimes what's easier oh, where'd my camera go? It's crazy. So sometimes what's easier is if you take your square piece of paper and you fold it into fourths, and you take your square of your comic and fold it into fourths, then it's easy for you to see relatively where each thing would be. So if you had a curve that looked like this on your little square, when you divide it into fourths, it makes it easier to see, oh, this kind of starts right in the middle of this lower quadrant. And then I can see how it kind of cuts this here and kind of hits this at about halfway up and hits this at about halfway over. So if you want to divide it into a smaller and look at where the lines go proportionally, then that might end up helping you. So then what I want you and your partners to do is think about these thought questions on the back. How are the proportions and scale factors in dilations? A dilation is an enlargement. A reduction is when you're making things smaller. A dilation is when you are making things bigger. So the cartoon was cut into 1 by 1 inch squares. And you'll be enlarging what you see on your little square to an 8.5 by 8.5 square. So when you think about what that scale factor is, when you see what the original size of the comic was, then, and remember this is in inches, so 1, 2, 3, 4, 5, 6, 7, 8, 9. If by 1, 2, 3, 4, 5, 6. So we can know what that original size of the comic is and then move along. So your comic is in color. My recommendations are that you do this, that you sketch it with a pencil first, and then that way you can, if you're sitting near somebody that has your same letter, you can double check, hey, what does yours look like compared to mine? Color pencils are in the back, so are black markers. You can take a look at, here's one row of the comic. Talk to me about the kids that used marker versus the kids that didn't. So the black marker makes a big difference. They're all back there, so you guys can work on that. I think these two got together the way that the A's match up exactly. I'm pretty sure that that was a coordinated effort. I'm fine with that. When you finish, I have a secondary puzzle that I started that I have half the blocks done from the other kids. So when you finish, we'll keep on going, and I'll give you more squares. Here's my secondary comic. It's obviously much smaller. The guy says, forget true knowledge. Tell me how to take tests. And that's what we're doing for the rest of the period. Questions? Okay. So you should have